Today's video I am going to show how to find out the adjoint and inverse of the matrix, and this topic is related to the matrices and determinants, and this topic is related to Diploma Mathematics 1. So first of all we have to find the adjoint as well as the inverse of the matrix. So I have given all the solutions in my previous videos. Please check the playlist, and here I have given all the solutions, and in today's video I am going to share the solution for 1 2 minus 2 minus 1 3 5 and 2 7 minus 4. So now I am going to calculate the inverse of the matrix as well as the adjoint. So first of all, for finding the inverse of the matrix we have to find out the determinant of A. For finding the determinant, so first of all this is 1 into, we have to close the corresponding row and column of 1, and here what remains? 3 5 7 minus 4. So this is 3 5 7 minus 4, and here this is minus 2 times of, now we have to close the corresponding row and column of 2. So then what remains? This is minus 1 5, this is 2 and minus 4, and here this is minus 2 times of, we have to close the row as well as the column. This is minus 1 3, this is 2 and 7. And now we have to find the determinant. For finding the determinant, so this is 1 times of, this is minus 12 minus 35, this is minus 2 times of, this is 4 minus 10, this is minus 2 times of minus 7 minus 6. Det A value is equal to this is minus 47. So this is minus 47 minus 2 times of minus 6, and this is 2 times of minus 16. This is determinant of A is equal to minus 47, this is plus 12, and this is minus plus 26. And the det A value is equal to minus 47 plus this is 38. And the determinant value is equal to minus 9. So after getting the determinant value, so I have to find out the inverse. So for finding the inverse, first of all we have to find out the cofactor of A. So for cofactor of matrix A, the formula here is minus 1 power, this is row number plus column number into the minor of A, minor of each and every element. I'll find minor of A. See here for cofactor, what is the question here? The question here is given as 1 2, this is minus 2, this is minus 1 3 5, this is 2 7 minus 4. So here the matrix A is given as like this. So here for finding, so this is A11, this is A12, this is A13. So this is second row, this is the second row, and this is first column, second column and third column. So this is third row, so this is third row and first column, second column and third column. So minus 1 power row number plus column number. So this will be minus 1 power 1 plus 1. So this is plus, minus 1 power 1 plus 2. This is minus 1 power 1 plus 3. So this is again plus. So and so on. Plus, minus, plus, minus, plus, minus, and again plus, minus, and plus. So now I have to multiply with minor of each and every element here. So for finding the minor of each and every element, so we have to find out all the values here. So for finding all the values, so this is A11, so A11 matrix, this is A12, so this is A13, so this is A13 matrix. Now I have to close the corresponding row as well as the column. So for finding the minor of each and every element, first row and first column I have closed, then the elements here are, this is 3 5, this is 7 minus 4, and if I close the second column, first row and second column, this is minus 1 5 2 minus 4, this is minus 1 5 and this is 2 minus 4. So if I close first row and third column, this is minus 1 3, this is 2 7, and the next one is B. So B, so this is the second row, first column, second column and third column. Then the matrix will be, see here, then the matrix will be, so I'm shifting to second row, and now if I close the first row, second row, first column, then 2 minus 2, 7 minus 4, this is 2. minus 2, and this is 7 minus 4. And if I shift to the second column, this is 1 minus 2, this is 2 minus 4. And if I shift to the third column, this is 1 2 and 2 7. And here column 3, sorry, row 3. So row 3 and column 1 2 and 3. Then the matrix will be, see here, the matrix value is, I am shifting to third row, first column I am closing. So this will be 2 minus 2, and this is 3 5. And here if you observe, this is 1, this is minus 2, and this is minus 1, and this is plus 5. This is 1 2 minus 1 3. This is 1 2 minus 1 3. So now I want the values for this. So this is minus 12 minus 35. So this value is minus 47. And the next value here is plus 4 minus 10. So the value here is minus 6. The value here is, this is minus 6. And see here, this is minus 7 minus 6. The value here is minus 13. And if you observe, this value is minus 8 plus 14. The value here is 6. And here this is minus 4 plus 4. The value here is 0. And here this is 7 minus 4. The value here is 3. And this is 10 plus 6. The value here is 16. And here 5 minus 2. The value here is 3. And this is 3 plus 6. The value here is 9. So we have to find out the cofactor. For finding the cofactor of A is nothing but this is plus minus plus minus plus minus, and this is again plus minus and plus. Now we have to substitute here. So if I substitute, so the values here are minus 47. So the first value is minus 47, and this value is minus 6, and this is minus of minus plus 6, and this is minus 13. And the next value here is 6 0, and this value is 3. 16 3 9. This is a 16 3 and 9. If I substitute all the values, and this is the cofactor matrix. So this is minus 47. So the cofactor is equal to, this is minus 47 plus 6 minus 13, and this is minus 6 0. This is minus 3, and this is a 6. This is minus 3, and this is plus 9. See here. So this is the value we got after finding the cofactor. Now adjoint of A is equal to, so adjoint of A is nothing but cofactor transpose. So we have to transpose the cofactor matrix so that we'll be getting adjoint of A. So adjoint of A is equal to, so now you have to change this column as row, that is minus 47 minus 6 6. See here, this is 16. So this value is 16. Minus 47 minus 6 plus 16. And this second column is second row, that is 6 0. This is minus 3. And the next one is minus 13. This is minus 3. And this value is, see here, this is 3 minus of minus plus 2. So this value is 2, and this value is 5. So here, if you see, the value here is 16 3, and this value is 5. And here also this value is minus 13 minus 3, and this value is 5. And here this is a 16, this is minus 13 minus 3 and 5. So after getting the adjoint, we have to find A inverse. A inverse is equal to adjoint of A by determinant of A. So A inverse is equal to, what is det A? So just now I found the determinant of A is equal to minus 9. So this is 1 by minus 9 times of adjoint, that is minus 47 minus 6 16. This is a 6 0 minus 3. This is minus 13 minus 3, and this value is 5. Therefore adjoint of A is equal to, A inverse is equal to, if I send negative inside, so this will be minus into minus, this is plus 6, this is minus 16, this is minus 6 0 3, this is 13 3, and this value is 5. 47, 6 minus 16, minus 6, 0, 3, and this is 13, 3 minus 5, and this is how we have to solve. And thank you so much for watching, and I'll be giving solutions for a few questions in my next video. Please have a look at those, and this will be very, very useful for your preparation. And thank you so much for watching.